bahaya.
A very good morning to our respectful Professor Dr. MAZLIN Binti Zahari. My name is Rubani Halanaki Subramanian and my team members are Tun Muhammad Shafiq Aiman bintun Abdul Razak, R.C. Aranaraki M. Ramesh, and Muhammad Tasnim bin Muhammad Khalis. On this beautiful day, we are going to discuss about the line integral and application of line integral. First of all, my dear teammate R.C. Aran is going to explain about the line integral.
Hello everyone. In mathematics, a line integral is an integral where the function to be integrated is evaluated along a curve. It is extend the concept of simple integrals to integrate that can be used to find areas of surface that curves out into 3 dimensions as a curtain does. The term part integral, curvilinear integral, and curve integral are also used. Line integrals have a variety of applications in real life. For example, in electromagnetics, they can be used to calculate the work done in a charged particle traveling along some curve in a force field represented by a vector field. Or in classical mechanics, they can be used to calculate the work done on a mass moving in a gravitational field. For example, we might want to figure out how many calories a swimmer might burn in swimming along a certain route where the currents in all areas can be accurately predicted. This will also require the use of line integral because the total work it needs to do will vary depending on the strength and direction of the current. So a line integral over the part shown in the slide will help determine the total work or calorie the swimmer will burn along the path. To find the arc length of the curve, we use ds dt equal to square root of x prime t square plus y prime t square plus z prime t square. To find the work done, we will use integration of vector f x xt yt zt dot product vector of r prime t dt. Okay, there are 3 types of parametric equation we be used to solve the line integral problems. For example, line segment, circle, and explicit equation. A line segment of a curve that move from x0 y0 to x1 y1. The parametric equation xt equal to 1 minus t times x0 plus t x1, yt equal to 1 minus t times y0 plus ty 1. For circle of x square plus y square equal to r square, xt equal to cos theta and yt equal to r sin theta will be used. For explicit equation, for example, y equal to fx, the xt equal to t and the yt is equal to ft, which is we get from y equal to fx. For example, in a parabola, y equal to x square, the xt equal to t and the yt will be equal to t square because when we substitute the xt inside y equal to x, it will become t square.
Before we proceed to the question, I would like to tell you about a few steps that we need in order to answer this question. Okay, for first, step 1 is we need to read the question and we need to identify which formula we need to use, either line segment, circle, or explicit equation. So for this question, we need to use line segment as for step 1's formula, and we need to find the xt, yt, and zt. And after that, for the step 2, we need to use the parametric formula to get the, and for the how to get the xt, yt, and zt, we need to use parametric equation. So step, and the next step is we need to find RT, vector of RT, R prime T, and FRT, and vector of FRT, sorry. And for lastly, step 3, okay, use formula work done. So formula work done has been explained before this, and I would like to proceed to the question. Okay, for the question is the force, and I would like to read the question first. The force exerted by an electric charge at the origin on a charged particle at the point xyz with a position vector r is equal to xyz is equal to Fr is equal to Kr over modulus of R cube. And the condition is when K is constant, assume K is equal to 10, find the work done as the particle moves along a straight line from 200 to 223. And the first clue and or hint that we get from this question is the work done. So the work done, we need to use the FR formula. And as the particle moves along a straight line, so we need to use a straight line equation to find the x, y, and z t. That's all from me. Thank you.
Now we want to do parametric equations for line segments from 200 to 228. Okay, for xt, we substitute 2 into x0 and 2 into x1, and the answer for st is 2. Then for yt, we substitute 0 into y0 and 2 into y1, and the answer for yt is 2t. And lastly for zt, we substitute 0 into z0 and 3 into z1, and the answer for zt is 3t. Then we substitute xt, yt, and zt into rt, and it becomes 2i plus 2tj plus 3k, and the range for t is from 0 to 1. And then we must find the modulus of rt, and the answer is in bracket 4 plus 13 times t squared, the power of 1 per 2. Then we calculate r prime t, and the answer is 0i plus 2j plus 3k by differentiate xt, yt, and zt. And lastly we calculate FRT, and the answer is 20 per in bracket 4 plus 13t squared, the power of 3 over 2 I plus 20t per 4 plus 13t squared, the power of 3 over 2j plus 13t per 4 plus 13t squared, the power of 3 over 2k.
For the step 3, as we know, the formula of work done equals to integral f times dr equals to integral fxt yt zt dot product with r prime t dt. As we show, work equals to integral 0 to 1 20 over 4 plus 13t square power of 3 over 2, then 20t over 4 plus 13t square power of 3 over 2, and 30t over 4 plus 13 square power of 3 over 2 dot product with 0 to 3 dt. Then we solve as usual by dot product. It become integral 0 1 4tt over 4 plus 13 square power of 3 over 2 plus 90t over 4 plus 13t square power of 3 over 2 dt. Then we kept the constant which is under 30 outside of the integral. Then integral from 0 to 1 t over 4 plus 13t square whole power of 3 over 2 dt. Then by using the substitute method, let u equals to 4 plus 13t square. which is du equals to 26t dt. It's become 1 over 26 du equals to t dt. Then we just substitute the 1 over 26 du, which is equals to t dt, in the formula, which is 130 integrate 0 to 1 over 26 u power of negative 3 over 2 du. Then it become 130 over 26 integrate 0 to 1 u power of negative 3 over 2 du. We just integrate as usual, which is 130 over 26 u negative 3 over 2 plus 1, which is negative 1 over 2 over negative 1 over 2 from 0 to 1, which is equals to 130 over 26 times negative 2 bracket 4 plus 13t square power of negative 3 over 2 from 0 to 1. And the solution is shown in the below, which is the final answer is negative 10 over square root 17 plus 5, which is approximately 2.5746. Thank you.